Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we have a new lesson. It's about adding and subtracting fractions with unlike denominator. Let's see. Bismillah. I have many strategies to solve this addition or subtraction of a fraction. Let's see here. The first strategy is to use the fraction wall. But what is the fraction wall? The fraction wall is just like this diagram. I have here what? I have here one whole. And we all know if I divide it in two pieces, it will be what? It will be halves and half. That's why if I stick the two halves, it will be actually the same as the length of the one whole, right? Okay, what about if I divide this one whole into three parts? It will be what? It will be third and third and third, right? So that's why the 3/3 here are the same as in length as the one whole. If I divide this one whole into four parts, it will be what? It will be quarter and quarter and quarter and quarter, right? And as well as if I divide it in five equal parts, it will be what? 1/5 and 1/5 and 1/5, 5/5, right? If I divide this one whole into six equal parts, it will be what? 1/6 and 1/6 and 1/6 and so on. You will see that you have just one like this fraction wall in your ministry book, and you can deal with it, or you can print it and you can cut it into pieces. You can use your scissors and you can cut it, and let's use it, or how we can use this fraction wall in solving, adding and subtracting fraction. Okay, let's start. Bismillah. I have here what? 1/2 plus 2/3. How can I use this fraction wall to know what is the answer of this addition? Well, first of all, I notice what here? I notice that I have what? In the denominator I have 2 and here I have 3. I already know last year how can I add fraction with like fraction. If I have 2 and 2, I can add or subtract the numerator, right? And I will find the answer. But here I have what? Unlike denominator. What is the meaning of unlike denominator? It means what? Two different denominator. I have here 2 and I have here 3. How can I use the fraction wall? Well, let's see here. I have what? I want to get 1/2 like this one. I will put it here, and I want to get 2/3. So I will get what? Yes, 2 parts from the third. Super. And I will try to stick them together like this. Now I have 1/2 plus 2/3, right? Okay, how can I know what is the answer? Well, I want to compare these small papers, or these small 3 fractions by all of these fractions. Well, before everything, I know this will be what? Very tall strip, right? Very tall piece of paper. And I think I can put the one to compare with. Let's see here. Yes, I have one, but I still have empty part. Well, this empty part looks like what? What do you think? I will choose which one of them. I can hear you. One of you can tell me I can use this 1/5. Let's try with this 1/5. No, I still have what? One extra thing here, right? So I can't use it. Even though I have 2 and 3, some of you can tell me that 2 plus 3 equal 5, but it's not right. So let will be, I will put it again, and I will choose what? Let's try smaller one. So I will try 1/6. If I push it very small piece here, it will be what? Just right, the right fraction. So the answer will be 1 and 1/6, as we see here. And as you see, what is the relation between this denominator and this 2 denominators? Yes, super observers, mashallah. Okay, I have here 2 times 3 equals 6. So I learned that somehow I know the new fraction will be what? Will have 6 as denominator. It can be 5. I can't add the denominators, but I can what? Yes, I can multiply them, and you will learn how can we get it by another way. Now let's try to subtract. Okay, 3/4 minus 3/6. Once again, I have what? Unlike denominator or different denominator. So what shall we do? Again, I want to take away 3/6 from 3/4. How can we do this? Okay, let's start with the first fraction. First fraction is what? 3/4. Okay, so I put 1 over 4 and 1 over 4 and 1 over 4. Now I have what? 3 over 4. I want to take away 3 sixths from it. How can I do it? Well, let's put 3 sixths under this 1 over 4 and 1 over 4 and 1 over 4, and let's see how can we get it, or how can we remove an equivalent to this fraction. Let's see here. I will put 1 over 6 and 1 over 6 and 1 over 6. I want to make a line here to know, yes, this is the start, and where's the end? Okay, I have here, this is the end. How can I take away 3 sixths from this part? I want to take away the equivalent. The equivalent means what? These two parts from here. So I will take this part away and I'll take this part away. Why? Because it's a subtraction, right? I want to take the second number from the first number. Now what's left now? It's 1 over 4, right? Okay, it's 1 over 4. How can we use another strategy, which is modeling, and I think it will be more easier for you to solve with, to add or subtract. What is the meaning of modeling? Let's see here. The question here is 5 over 8 plus 1 over 4. How can I add this? By modeling. Well, how can I module the 5 over 8? Well, 5 over 8, how can I draw it? Yes, I will draw a circle and I will divide it into 8 pieces, right? And I will color 5 pieces, right? Just like this. I have here 1, 2, 3, 4, 5, 6, 7, 8 pieces, and I colored 1, 2, 3, 4, 5. And I want to add what? 1 over 4. Well, how can I do it? Yes, I will draw another circle and I divide it into, yes, 4 pieces, and I will color just 1 piece, just like this one, right? 1 over 4, like this one. Okay. So how can I add this part with this parts? Okay, this sector or this part of the circle is very large for this one. Okay, how can I divide this more to make it 8 parts? Can I? Let's try here. I will draw this line and I will draw this line. I will divide into sectors in 2 pieces. Now I have how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. And this quarter represent how many 8s? Yes, it represents 2 8s. Now I have equal sectors or equal parts. Yes, I have. Now I can add 2 to this 5. Yes, when I do this, I will draw another circle with 8 parts. And this time, when I add them, it will be what? 5, 1, 2, 3, 5, 6, and 7, 6 and 7, 8, 7, right? Okay, so it will be what? Yes, another circle with 8 parts, and I have now what? 1, 2, 3, 4, 5, 6, and 7. So the answer is what? 7 over 8. So as you see here, I can get what? I can get an equivalent to 1 over 4. What is the meaning of equivalent? I want to make equal fraction as we learned it before in lesson 1 to 1 over 4 with that same denominator, which is what? 8. How can I do it? I multiply up and down by 2. 2 and 2, it will be what? 2 over 8. Now I have like denominator, so I will solve as we learned before. Okay, I have another example here. I have 5 over 6 minus 2 over 3. Once again, I will represent the first module, which is what? Or the first model, 5 over 6. I will draw a circle with 6 pieces and I will color 5 pieces of it, like this one. 1, 2, 3, 4, 5, 6. And I colored what? 5 pieces. Subtract or minus what? 2 over 3. How can I cancel 2/3 from this? Well, let's see. I will draw another circle with 3 parts this time, like this one. Okay, and I will color 2 pieces. Okay, how can I make an equivalent to get 6 pieces here? How can I do it? Yes, I can hear you. I will draw a line here, another line here, another line here to get what? To get 6 pieces, right? Okay, now I have 6 pieces. Yes, 1, 2, 3, 4, 5, and 6. Now this 2 over 3 represent how many sixths? Yes, it represents 4 sixths. Super. Now can I subtract? Yes, I just want to remove what? 1, 2, 3, 4 pieces from this pieces. So 1, 2, 3, 4. Now what's left now? Just 1 piece, which means 1 over 6. So the answer is 1 over 6. Once again, when I don't have when I have unlike denominator, so I can change them to get what? An equivalent fraction to make the subtraction, right? Okay, now we will get to the number 3 strategies, or the third strategy. How can I add or subtract unlike denominator fraction just by what? By math, without any drawing, without any fraction wall. How can we solve it? Let's see the first problem. The first problem here is what? 3 over 10 plus 4 over 15. I have what now? It's not like denominator. I have unlike denominator. So what should I do? As you learned before, how can I get common denominator? By using, yes, LCM. So I have to find the prime factorization of 10 and the prime factorization of 15 and find the LCM. Let's see here. 10 is, yes, it's a composite, so I will put it inside the box. And 10 equals, yes, 2 times 5. 2 is a prime, yes, circle and leave it. 5 is a prime, yes, circle and leave it. What about 15? 15 is a composite number, so I'll put it inside the box. And 15 equals, yes, 3 times 5. 3 is a prime. Yes, it's a prime. 5 is a prime. Yes, it's a prime. So I will circle both of them and leave them. Now we can write 10 equals 2 times 5. And 15 equals 3 times 5. Don't forget to line up your numbers. The numbers which are equal, I will put them under each other. If I don't have equal numbers here, I will leave them alone. How can I find the LCM? I will take what? 1 of here, 1 of here, and 1 of here. So the LCM equals 2 times 3 times 5, which is, yes, equals 30. So the least common multiple is 30. Now, how you have another way to find out the LCM? Yes, you can find it by what? To write down the multiples of 10. The multiples of 10 are what? Under the multiples of 15, and you will find out the least common multiple. The multiples of 10, 0, 10, 20, 30, 40, 50. What about the multiples of 15? It will be somehow tricky. That's why I prefer to find out by using the prime factorization like this one. So the multiples of 15 will be 0, 15, then add 15, it will be 30, then 45, then 60, then 75. Where can we stop after you find out at least 5 multiples of each? Now we can compare them. Which one is the least common multiple, except the 0, of course, not including the 0. So I will choose what? Yes, I can find that it's 30 again. Now I have to rewrite each fraction by what? By the new denominator, which is 30. Okay, how can I make it equal 30? Yes, I'll multiply up and down by 3. Why? Because I want to change this 10 to be 30. 3 times 3 equals 9. So the new fraction here would be 9 over 30. Plus, what about the second one? Well, how can I convert the 15 to be 30? Miss, it's not easy. But if you have the LCM like this, it will be easy. How? Where is the 15? 3 times 5 equals 15. Times what here? Yes, it's times 2. So I know if I want to convert the 15 to be 30, I will multiply it by 2. So I multiply up and down by 2 to find out it's what? It's 30. So 4 times 2 equals 8. Now, can I add as we learned before? Yes, of course. I will leave the denominator as it is, which is 30. 9 plus 8 equals 17. 17 is smaller than 30? Yes. Okay, I have any common factor between 17 and 30? No, of course not, because 17 is a prime number, so I can leave this fraction as it is. Okay, I have now an example for subtraction. 4 over 5 minus 3 over 10. How can I find common denominator? Well, this time it will be super easy. Why? Because we have to look here. The denominator here is 5 and the denominator here is what? Is 10. Both of them in the same table? Yes, of course, 10 is a multiple of 5. So leave the big one as it is and you can change the other one. 5 can be 10. Yes, of course, 5 can be 10. So I will choose the common denominator to be 10. Okay, you can solve it, of course, by using the prime factorization, but it will be easier for you to know that 10 is a multiple of 5, so the least common multiple is 10. Now, how can I convert the 5 to be 10? multiply up and down by 2, of course. 4 times 2 equals 8. What about the other fraction? I have to change anything inside it? No, I have to change nothing for this fraction. 3 over 10, I have already, the denominator is 10, so I will leave the numerator as it is. It will be what? 3. Now, can I subtract? As we learned before, of course, leave the denominator as it is. 8 minus 3 equals 5. Now, 5 is bigger than 10? No. 5 and 10 can be divided by anything or having any common factors. Of course, both of them can be divided by 5. So we have to simplify it. How can I simplify it? I will divide up and down by 5 to find the simplest form. Okay, to put the answer in the simplest form. 5 divided 5 equals 1, and 10 divided 5 equals 2. And if you have a good observation, you can see that the 5 over 10, it's already the half of 10, right? So it's equals to the half. I have another example here. 2 minus 7 over 9 minus 1 over 6. Well, where is the denominator? 2, it doesn't have any denominator. Okay, let's look here. I have what? I have 9 and I have 6. Let's find out what is the least common multiple between them. Okay, 9 is what? Yes, it's a composite, so equals 3 times 3. 3 is a prime? Yes. 3 is a prime? Yes. So circle both of them and leave them. What about 6? Again, 6 is a composite number, so equals what? 2 times 3. Both of them are prime? Yes. Circle them both and leave them. Now I'm ready to find out what is the LCM. Okay, 6 equals 3 times 2. What about 9? 3 times 3. And the LCM, don't forget to line up your factors. LCM will be what? 3 times 2 times 3. 3 times 2 times 3 equals 18. So the new denominator will be what? Will be 18. But Miss, 2 doesn't have any denominator. How can I make a denominator for the 2? Well, all of us know that the denominator of the whole number is 1. Super, because any whole number has a denominator equal 1. 2 over 1 equals 2, right? I didn't change anything, but I want to make this one to be what? To be 18. How can I make it? I multiply up and down by 18. 2 times 18, you can make it on your rough work. 2 times 18 equals what? Equals 36. So instead of writing 2, I will write it as 36 over 18. Okay, what about the second fraction here? 7 over 9. I have to make it what? 18 again. How can I make 9 to be 18? Look here. 9, which means 3 times 3. I will multiply it by the 2. So I multiply up and down by 2. 7 times 2 equals 14 minus. I still have to find the equivalent to this 1 over 6. Well, how can I make 6 to be 18? Once again, look here. 3 times 2 equals 6. I multiplied by 3. So I multiply up and down by 3. 1 times 3 equals 3. Now I have the same denominator. Like denominator, yes, so the answer, it will be what? Over 18. What shall I do here? Here I have 3 numbers, miss. What shall I do? I will use the order of operation. I will subtract 36 minus 14, then minus 3. We can use here in the rough work. I know 36 minus 14 equals 22. Then I subtract again 3. 22 minus 3 equals what? Equals 19. And I will put the new fraction. Don't move till you ask yourself, is the numerator smaller than the denominator? No. So what shall we do? This is called improper fraction. How can I convert this improper fraction into proper fraction? I have to put what? Ask yourself, if I divide 19 divide 18, or the 19 has how many 18 inside it? It has just one 18. So 19 divide 18 equals just 1, and the remainder will be 1. So I will put whole number and 1 over 18. So the answer is 1 and 1 over 18. That's all for today. See you soon, inshallah.